Am I going to teach tomorrow? I don't know. Yeah, it looks like it. Oh, PSATs? You're taking those tomorrow?
Can you give us a free study?
What?
It'll give you time to catch up on
Crazy?
notes and like all that stuff.
Oh, is that what it would do?
It would. If you want, I can help you grade. Especially if you're having a rough go, like
I'm not having a rough go. I'm good. All right, let's throw something else in here. So here's an equation that we're going to do. We're going to use this quite a bit, and these letters all tell you something. You already know what probably two of these do, and we just, before we started recording, we talked about how to move it left and right, and so you're going to see that in here as well. So this is pretty good. So when you see something that looks like this, you're like, oh, I know what that number does to my graph. I know what that number does to my graph, right? So this is a quadratic. It's a quadratic when you have something that's squared. When you have x squared, they consider that to be a quadratic. If you have it cubed, they call it a cubic. I think they might even list them. I think I saw that in here somewhere. I don't know if it was this. Was it the next chapter or the next section? Yeah, so if you have cube instead of a quadratic function, that'd be a cubic function. If you have 4, they call it a quartic function. If you have 5, they call it I think it's a quintic. Lily, find that page for me where they have those, if you see that somewhere. But they do have weird words for it. We don't really refer to them all that much. Every once in a while we might. 272. Wow, it's way out there. 272. Let me find it. Yeah, there they are. Section 6.8. We're only on 6.2 right now, but 6.8, they talk about these words. Quadratic, cubic, quartic, and quintic. I was correct. Again, we don't use those words a whole lot. Quadratic we use a ton. Okay, cubic we use a lot, but then after that, they kind of just don't really use the names all that often. But anyway, so there's other words than just quadratic. But quadratic refers to this being a square. All right, enough of that. Let's talk about what these letters do for us. Okay, so what if we had a number right out here? What is that number doing to our basic quadratic function? It's making it steeper, or?
Well, it depends if it's a fraction.
I know, that's the or. Okay, actually I should put plus or minus right here. They don't do that, do they? Do they put a plus or minus? Yeah, they don't say plus or minus, but let's put that in there anyway. All right, because the plus means what's the graph going to do? It's going to do what? It's going to open what? Up, right, upwards, right. It's going to open up, and if it's negative, then it opens down, all right? The number right here, what does that tell you? It could do this or it could do that, depending on what kind of number that is. It makes it what? It makes it steeper or, flatter, okay? Is that the word they used? Is flat? Okay. So it could make it steeper or flatter. How do you know if it's going to make it steeper or if it's going to make it flatter? If it makes it steeper, then that A has to be what? Greater than, not 0, 1. Greater than 1. And if it makes it flatter, is that correct? Yes. Can we say wider? I don't know. What does the book say? Let's say what the book says. What does the book say? Yeah, but I want to stay consistent with the book. We could say wider. It's fine. I probably would normally say wider. But what does the book say? Because you just had those problems. It says flatter. They say flatter. Let's use flatter, okay? But you get the idea, right? So here's your normal quadratic, all right? This would be a steeper quadratic, and this would be a flatter quadratic, okay? So that's what that A tells us, right? So how do I know if it's flatter? Then it's going to be less than. X is less than 1. It's actually between 0 and 1, okay? Because less than 1, you could have like a -3, that would make it steeper. It just flips it. All right. So technically it would be, let's see, between 0 and 1. All right. So that would make it flatter. Okay, good. Let's skip the h right now. Let's go to the k. What does that k do to us? If you add a number, if you add a constant, k for constant, even though constant starts with the letter c, we can think of it as k and constant. All right. What does that do? It moves it what? Up and down. Yeah. What was the word we used? We used a fancier word. Not transient, translate. Okay, we translate it just in case you hear somebody that's super smart and they use the word translate. All right, they don't have to be super smart to say that, but you get the idea. Instead of just moving it up and down, we translate it up or down or shift it. Okay, shift would be a good word as well. Or you could just say move it. It's fine. I don't mind if you say move it up or down. All right. Now, what does this h do for us? This moves it what? Or translates it left and right. Okay. So left or right. Now, look at how, remember we said it didn't make sense? Like if I remember the one that I did before we started teaching, this moves it where? To the right. It looks like it might move it to the left, right? Because that minus. But look, it starts off with a minus, doesn't it? So really, the h is not negative. The h, or the 3, is really what? It's positive, but the equation says you subtract it. Okay, does that make sense? You're subtracting a what? A positive 3. So this would move it to the right 3 places. All right, now it makes a little bit more sense, doesn't it? Why the negative makes it go to the right. It's really not negative. It's minus whatever the h is. Okay, the h moves it left or right. If the h is negative, that would mean it's minus a negative. Agreed? All right, which would be a plus. So when you see like x plus 2, this really is the same thing as x minus what? Negative 2. Do you see that? So that means that your h right there, the h is actually what? Negative 2, which means it moves to the left 2. You understand that? Okay. And right here, what is your h? It's not negative 3. What is it? It's a 3. But our little formula, our little equation says we subtract whatever the h is. All right. I don't know if that makes it any better or not, but that's why it does that. Let's grab this thing, get that out of the way. All right. So that's pretty important for quadratics. All right. So that's what we're going to use. So they still, on this one, they are still using the tables. All right. I want us to try to get away a little away from using the tables. I don't think in section 6.3. I think they go right out. Yeah. They use the tables, but I think we can kind of figure this out on our own. So let's look at the first example. So they say g of x this time. It's fine. Just because the other one said f of x. G of x just means it's a different formula, or not formula, but function. All right, and this is what? X minus 2 in parentheses, x minus 2 squared. That's g of x, and then you've got h of x, and that is x plus 3 in parentheses squared. Right? And what we're doing with this is we're comparing it to the f of x. So what do you think the f of x is? It's just plain old x squared. All right. So let's put it into that form. Okay. Let's do the g of it. Let's write it with all the stuff, the a, the h, and the k, right, and all that good stuff. So watch. How would I write it? Remember, plus or minus. So what's our sign? It's plus. What's our a? It's a 1. And then what is it? X minus h, which is 2, plus k, which is 0. So that's technically how you would write this. But you don't need a lot of that stuff, do you? Okay, if it's already positive, you don't need the positive. If it's a 1, you don't need the 1. But that tells you something. What does that positive tell you what does it tell you that does? It opens what? Up. All right, and this one, the 1 right there, means it's the same shape. It's not steeper or flatter than an x squared, a regular old x squared graph. All right, that's what that 1 tells you. This right here, this tells you it moves to the what? To the right. So that's what that tells you. And this one means you move it up and down 0, which means you don't move it up and down, okay? So it doesn't go up and down, but it does go to the right 2 places, and it's the same shape. It's not any steeper or flatter, and it goes up. So that should make sense to you. Do you agree? So if you're going to graph this by hand, and you didn't have any graph paper, what would you do? You would move it where? To the right 2 places, wouldn't you? All right, let's do that in a different color. All right, so that would be your vertex right there. And it opens up. So is that vertex, is it a minimum or is it a maximum? As your thing goes up, as your parabola goes up, what's that vertex? That's the very bottom of it, isn't it? Okay, so that would be a minimum. What if it had a negative in front of it and your parabola went down? Then it would be a maximum. Make sense? Because it's at the top of the graph. That's how you want to think of it. All right? So again, generally, we don't have to be super, super accurate with this, but generally, here's what you would do. Here's what I would do if I was to graph this thing. All right, put a 1 here. I'm going to go a couple. Let's say 2. Yeah, that's good right there. And then I'm going to go 1, 2, 3, 4. Okay, everybody watching? So here's what I want to do. If I go over 1, it starts here. If I go over 1, I go up 1. Right? This tells me how steep the thing's going to be. Why? Because if I put a 1 in for x, 1 squared is 1. So if I go over 1, not to the number, well, actually this does work, but if I go over just 1 place from my vertex, right, I go up 1. If I go over 2 places from my vertex, what do? 2 squared, which is 4. And that's good enough to get me started. Wouldn't you agree? And then look, the other side's a mirror image because it's symmetrical, right? On a parabola, the one side does the same exact thing as the other side does. So if I went to the left 1, then I'd go up 1. If I go to the left 2, I'd go up what? 4. You see that? All right, and now, if I can graph it, that's not half bad. It's better than I was doing the other day. Still not too great here, a little flat there, but you get the idea. All right, so that's what it would look like. Make sense? So did we really have to do all this stuff? Not really, okay? Now, there are times it's going to be super helpful when we're going to do some complicated ones, and there are times when you might want to do this. And we actually kind of did it in our head, didn't we? We went over 1, right? I stuck that in here. 1 squared is 1, so I go up 1. I went over 2, right? So, but you didn't really have to write the table for that, did you? Not for a squared. So if I went over 2, that means I go up 4, right? Because why? 2 squared is 4. And then the other side is just the same. I don't even have to do the math with that. If I went to the right 1, I went up 1. If I go to the left 1, I go up 1. If I go to the right 2, I go up 4. If I go to the left 2, I go up 4. Symmetrical. And that's basically graphing quadratics. Basically. It gets more complicated later on, but that's kind of what they want you to see and what that little formula, that little function is good for. Okay, what if we had something like this? Go back to white. All right, what if we had this? P of x, you can use any letter, it doesn't matter. Okay, P of x is equal to x minus 2 squared, minus 3. And again, we're going to compare it to our basic quadratic function, which is just x squared. All right, so let's go through it. What do? How does this thing open? Watch, I'm going to draw a graph. How does this thing open? Up or down? It goes up. Okay, what about the steepness? Is it wider or steeper? It's the same as this one. Okay, now this is important. This number right here and this number right there. Okay, that tells us stuff. This tells us if we move it left or right. So what am I moving? I'm moving to the what? Shift it to the right 2 places. Okay, 2 places. All right, and what does that tell us right there on the end? That constant, that k, that goes what? Down. Okay, so this is down what? 3 places. So what's our vertex? That kind of shows us what our vertex is. Our vertex is basically, we could write it with letters if you wanted to, because what was the letter for this number right here? It was H. And what was this number on the end? That was K. So this is our what? Is our vertex. So if we can get it in this form, sometimes they don't write it in that form. Sometimes you're going to have to factor it and put it into that form. All right, but if it's in this form, you can look at it and you can tell what the vertex is right away. All right, and what is our vertex? What is our vertex with this equation right there? It's 2, -3. That's right. So it's 2, -3. That's super helpful. That gives us a great starting spot, great starting place. All right, so 2, -3. 1, 2, 1, 2, 3. There it is, right there. I'll put a couple more in here. Yeah, that's good enough. I'll put one right there, okay? Everybody see that? So that's a good starting spot. That's our vertex. Now, how do I know? Do I graph it out like this or do I graph it like this? Well, what's the best thing to do? You could, I guess, if you wanted, you could put a table, right? You could put some numbers in and see what it looks like. But here's what I would do. Remember, this is 2. And this is -1, -2, -3. This is a 1. So what can you do? If you go over 1, you go up what? You go up 1 because it's a quadratic. Everybody see that? And it's a 1 in front of this, okay? So it's not steeper or flatter. You just go over 1, up 1. And then you do the same thing with the other side. To the left 1, up 1. And then you go over what? 2 and up 4. That'll put you right there, wouldn't it? And you go over 2, right there. You go up 4, it'll put you there. And there you go. You got your graph. And, whoops, almost. There you go. And that's basically what it looks like. Just like that. Does that make sense? Wouldn't you agree that's a little bit better than doing this stuff? And then trying to pick numbers, -2, -1, 0, 1, 2. I'm not really sure what numbers I would pick. You know, sometimes you get lucky. Sometimes then you might have to do some work to figure out where the x-intercepts in, and then you come in 1 from the x, you know, all that kind of stuff. You could do that. But when it's fairly basic, these are fairly basic, and it's in that form, it's not too hard. Let's do another one. Tell you what, let's use graph paper on this one. But I'm just showing you at the beginning, I just put an x and y axis just to show you that you can just do it on regular paper. Just put a horizontal line and a vertical line, you should be good to go. But let's do it with graph paper. It might be a little bit nicer and neater. All right, so we'll put that right there. And what is it? It's Q of x this time. They're really going for the crazy letters. Is equal to -1/2. And then x plus 4 squared and plus 1. Okay? Now they changed it up a little bit on us. First of all, they put a negative, so now this thing's going down. All right, they put a 1/2. What's that doing for us? The 1/2? What are you talking about? What are you talking about? You're sleeping the whole time. How would you know? All right, 1/2. Sorry. Just saying the truth. So 1/2. What is that going to do for us? It's going to make it what? It's going to make it flatter. Okay? What's this plus 4 right here? What does that do? Moves it to the left 4 places. What does that do for us? Moves it up. So what is the vertex of this thing? You should just be able to look at it and tell me what the vertex is. Negative 4, 1. Right, it's negative 4, 1. Because remember, this is x minus what? Negative 4, right? So the h is negative 4. And then this is just whatever the sign is. That's a 1. So that's the first thing I'm going to plot. Is negative 4, 1. 1, 2, 3, 4, 1. All right? So instead of going over 1, up 1, by the way, it goes down as well, right? You know it's going to go down. But how steep do I go? I'm going to go wider, correct? So a normal one, okay, would go here and here. If it was just regular, if there was just a 1 out in front, would you agree? It would go here. But this goes wider. So what's it going to do? It's going to go, instead of here, you got a 1 over 2. You could just plug it in if you wanted to. You could do your little chart, your XY chart, and throw it in. You could do that. But what's a better way to do this? I'm just going to look at what they do. I just want to make sure I do this right. Did I do that right? Hold on. Let me look at it. This thing's so small. 1, 2. Hold up. Oh, okay. I see what they did. Yep. So watch. Instead of going over 1 and down 1, this is going to go over 1, down a half. Do you see that? And then it's going to go over 1, down another half. Or you could have done what? You could have gone over 2 and down 1, right? And then from here you could do it again. Over 2 and down 1. Make sense? Okay. I think I did that right. 2, 1, 2, 1. Yeah, and it's going to be kind of wider. All right, so it's going to go. Is that right? Did I do that right? This is one thing I was thinking about as I was doing this. I was like, let's get rid of that. It'll get out of our way. Yeah, that's right, because over 2. Down 1. 1 half. Oh, I got to square it. I'm stupid. Of course. Yeah, it's not just, it's no wonder it looked like a straight line. Because you got to square it. So watch. If I go over 1, I'm not going a half. Let me just make sure. Yeah. Yeah, you are. Because if I go over 1, I'm taking that 1 half. Let me think. All right, here we go. This is how we're going to do it. I think I got this now. If you go over 1, if you go over 1, you multiply it by a half and then you square it. That's what we're doing, okay? If you go over 2, then you do what? Multiply it by a half and square it. See that? Okay? If you go over 3, then you go 3 times a half and square it. So let's do that. So 1 times a half is a half. I think I did that right. Oh my goodness. This is why I take notes, so I get this all figured out in my head before I come up here. And I didn't take notes on this lesson. So, yeah, that's 1 half squared. So if I go over 1, I go down a fourth. Is that right? Well, sorry about this. I'm embarrassing myself. You could go back to the original. Let's do this. Let's go back to the original. q of x without all that mess in there. Negative 1/2 times x plus 4 squared plus 1. So you could just put the number in. So like if you go over 1, all right, you got to figure out where the next one is. So where are we here? We're at negative 4, 1, correct? So this would be negative 3. Actually, let's put a negative 2 because it might be a little easier. Nah, it wouldn't make any difference. Let's put a negative 3 in for x. So we'll go back to that chart, right? Put a negative 3 in. Let's see what the y is. So if I put a negative 3 in, what do we get? Negative 3 plus 4 is 1. 1 squared is 1 times negative 1/2, which is negative 1/2 plus 1 gives us 1/2. And that's where we said it would be, right? If you go over 1, you go down 1/2. What if you went over 2, though? To where? Where is that point? Negative 2. Let's put a negative 2 in for this. So let's get rid of this. So if you put a negative 2 in for this, negative 2 plus 4 is 2, squared is 4, negative 1/2 of 4 is negative 2, add a 1, you get negative 1. So if I put in a negative 2, where am I? At negative 1. And that is where I said it should be. Remember that? Let's do one more just to get us in the right spot, because that might not be quite enough to get a good one. Here's a good way to do it. Put in a 0 in for x, all right? And that'll tell you your y-intercept. So that'd be a good number to know. 0 plus 4 is 4 squared is 16. Half of 16 is 8. Negative 8, right? Because a negative plus 1 gives you what? Negative, plus 7. I was thinking what the number was, what the answer was. Negative 8 plus 1 is negative 7. So it would be down in here. See that? Should make that red. All right, so there's our graph. And on the other side, I don't have to do the math again, right? I don't have to put all those numbers in here because I know they're right across, right? So how far did I go from here? I went over 1, 2, 3, 4. So I just go over 1, 2, 3, 4 right there. And there's the graph right there. Looks like a little, making it worse. It's not that easy to graph on this tablet thing. All right, there it is. It kind of looks like it. All right, and that's what your graph would look like. All right. So that's what I would do. I would just put the numbers in because there are times when we kind of did a hybrid. All right, we kind of knew where it started and all that. Then we put some numbers in, and then we're good to go. All right, let me just look at the rest of it. I know time's running out here. Example 4 and 5. Yeah, example 4, you probably could figure it out, but we'll do 4 and 5 tomorrow. Yeah, so let's just put a hold on that. I would say this: do as many as you can. I'm not going to collect it tomorrow, but your assignment is 13 to 33. I'm just having you do the odds because graphing a whole bunch of those takes a lot of time. So do as many as you can. You'll get to a point you're like, oh, we didn't see that. Because here, I'll give you the example. Like if you had something like this, x squared plus 3x plus 1, what you're going to have to do is you're going to have to do some algebra with this. And we'll talk about the algebra tomorrow. We'll do that tomorrow. So if you see stuff like this, you probably can't do it. But if you see stuff written like this in that form that we talked about today, you should be able to do those. All right.